All right, everybody, Mr. Antonucci here with number 2 from the 2024 AP Calculus AB exam. Free response question number 2. So here we have a particle moves along the x-axis, so its velocity at time t greater than or equal to 0 is given by the function v of t. Here we have the function here. I previously put the function in my y equals menu because I know I'm going to be using that. So part A, there is one time t equals t of r in the interval 0 to 2 when the particle is at rest, meaning not moving. Find t of r for 0 to t of r. Is the particle moving to the right or to the left? Give a reason for your answer. So, in order to determine whether the particle is at rest or not moving, we need to graph the function. Since it's the interval 0 to 2, going to go like that, and then the y values, we're going to go -5 to 5 and make our x scale 1. Going to graph it. Okay, I fixed the graph there. So the reason we're graphing the velocity function is because the object's going to be at rest when its velocity is 0, and we can see that the velocity changes from positive to negative at some time. So yes, it is going to be equal to 0, so we're going to solve for that using number 2, the intersect command. Pick a point to the left of the intersection. Pick a point to the right of the intersection. And then put your guess on the intersection, and there we go. So we would write, t of r equals 1.4256. Now you only need to go out 3 decimal places, but I like to go out a couple more. Since v of tr equals 0. So is the particle moving to the left, right, or 0 on that interval? The particle is moving to the right, since v of t is greater than 0 on the interval 0 is less than t is less than t of r. And you can see that from the graph. Okay, you can't just put a sketch of the graph, you have to write the sentence. Okay, part B. Find the acceleration of the particle at t equals 1.5. Show the setup for your calculations. Is the speed of the particle increasing or decreasing at t equals 1.5? So acceleration at 1.5 is equal to the derivative of the velocity at 1.5, which we could do on the calculator. So since I already stored the function in the y equals menu, I don't have to type it in again. So math choice number 8 is going to be the numerical derivative. You hit the variables, y variables, function number 1. I put it in y1, so this is going to do the numerical derivative of the function I already put in y1 with respect to x at 1.5. Now the calculator uses an algorithm that's only accurate so many decimal places, but if you go out 3 decimal places, that's going to be equal to -1. Okay? Now, that's the acceleration. Wants to know is the speed of the particle increasing or decreasing. So we would say speed is increasing, or increasing. Since v of 1.5 equals, now if we want to get the velocity, you can just hit variables, y variables, number 1, and then put in parentheses here 1.5. That's going to tell us the velocity is -0.70 negative 0.077, and a of 1.5 equals negative 1, or both have the same sign. Okay, so remember, when velocity and acceleration have the same sign, the speed is increasing. When they have opposite signs, the speed is decreasing. Okay, so part C, the position of the particle at t is x of t, and the position at t equals 1 is x of 1 equals negative 3. Find the position of the particle at t equals 4. Show the setup for your calculations. So this is wanting to know final position of the particle. So all we need is the initial position plus the change in position. So the initial position is given by x of 1. The change in position is the definite integral from 1 to 4 of v of t dt. So x of 1 is negative 3. And then on the calculator, we can hit math. Choice number 9 is the numerical integral. Since we already stored the function, we can go to variables, y variables, function number 1, comma, x, comma, 1, comma, 4. Remember, the definite integral of velocity gives you change in position. So if you do initial position plus change in position, it's going to give you the final position. Okay, so that's 0.197116. So if I add the negative 3 to that answer, we're going to get negative 2.803. That's going to be the final position. All right, so part D, find the total distance traveled by the particle over the interval 1 to 4. Show the setup for your calculations. Now, total distance is the integral of the absolute value of the velocity. So, again, math number 9. But now we have to put the absolute value command. So you hit math over to number. Absolute value is the first function there. Then we can recall function stored in the variables menu. Close the absolute value, comma, x, comma, 1, comma, 4. And this is going to give us total distance traveled. Now it takes the calculator a couple seconds because it has to do the numerical algorithm to find the definite integral and also do the absolute value of the function. So sometimes that takes a little bit of time to calculate, but accurate to 3 decimal places, we get 0.958. Okay, there you go. And again, I worked these out ahead of time and also cross-referenced them with another resource to double check my solutions. So I'm fairly confident they are correct and accurate, although at this time the solutions in the scoring guidelines have not been released by the College Board, so I do not have the scoring breakdown for these. All right, guys, Mr. Antonucci here. Hope that was helpful to you. Take care.